personality interacting with the frequency bands/range of the AI astral planes, both self-identities, as the frequencies that represent those identities resonate/vibrate within the simulation, not outside/beyond it, keep you within the endless cycle of reincarnation of the simulation to be a permanent lish producer. Evidence that supports the simulation. Evidence supporting the simulation theory includes the rapid advancement of virtual reality (VR) and artificial intelligence, the mathematical and pixelated nature of the universe, and quantum mechanics, where particles exist in uncertain states until measured. These, combined with that observer effect, suggest a rendered reality rather than a fundamental one, often described as a cosmic computer. Key evidence and arguments. Technological projection. As VR and AI advance, simulations indistinguishable from reality appear achievable, making it plausible that advanced civilizations could simulate us. The observer effect/quantum mechanics. In physics, particles in hidden places do not seem to have definite states, locations, or properties until they are observed or measured, which mirrors how video games only render parts of the world a player is actively viewing. Pixelated universe. Certain quantum phenomena suggest a limit to space and time, similar to the discrete resolution or pixelation of a computer simulation. Mathematical structure. Physical laws, mathematical equations, and geometric patterns, like fractals, are omnipresent, suggesting a computer-generated structure. Quantum entanglement. This phenomenon connects particles across distances faster than light, which could be explained by them being simulated adjacent to each other in a central processing system. Information-based reality. Some theories suggest that data is the fundamental building block of the universe, not matter, as if the universe is made of code. Gravity as data management. A recent theory suggests gravity is a tool for the universe to organize data, similar to a computer managing information overload. Quantum mechanics weirdness. Phenomena like the double-slit experiment, particles behaving as waves until observed/measured/decoded, superposition, and wave function collapse resemble how a computer simulation might optimize resources, rendering only what's necessary when observed by a conscious entity, rather than computing the entire universe in full detail at all times. Some interpret quantum indeterminacy and the observer effect as signs of underlying code or efficient evaluation in a program. The holographic principle. In theoretical physics, from string theory and black hole research, the information describing a volume of space can be encoded on its lower dimensional boundary, much like a hologram. This suggests our 3D, or 4D spacetime, experience might be a decoded projection of information from a 2D surface. Proponents link this to simulation ideas, where reality is fundamentally information-based rather than material. Fine-tuning of physical constants. The universe's fundamental constants, e.g., gravitational constant, strength of electromagnetic force, electron mass, appear precisely calibrated to allow stars, planets, chemistry, and life. Tiny changes would make the universe sterile. In a simulation, this could be explained as deliberate parameter setting by the simulators, rather than pure chance or a multiverse. Second law of infodynamics. Physicist Melvin Bopson has proposed that information systems show decreasing entropy, opposite to the second law of thermodynamics, suggesting built-in data optimization and compression, exactly what an efficient simulation would need to minimize computational resources for a complex universe. He argues this applies across digital data, biology, symmetries, and cosmology. Discrete spacetime and testable signatures. Some physicists, e.g., Silas Bean, Zare Davuti, Martin Savage, note that a simulation with finite resources might use a lattice or grid for spacetime, potentially causing observable effects like anisotropy, directional preferences, in ultra-high-energy cosmic rays. No such clear signature has been found yet, but it offers a potential way to test the idea. The Fermi paradox angle. The lack of visible extraterrestrial, alien/non-human life, civilizations could mean we're in a controlled or limited simulation, as the programmers want the universe to be devoid of intelligent life as it suits their control agenda/system. The Fibonacci sequence and golden ratio show up in many natural growth patterns, especially in plants, phyllotaxis, and some spirals, which can look like simple rules generating complex results. Fractals are self-similar across scales, so they naturally suggest generated structure, the way a recursive algorithm can produce complexity from a few rules. Pi appears everywhere in circles, waves, and periodic systems. Because all of these can be described compactly with mathematics.